we are going to try and find out the areas between curves and lines, okay? What you may actually eventually be able to do is you may be able to find the area between two curves like this. So instead of it always having to be the area between a curve and the x-axis, we can come up with much more interesting kinds of areas that we might be trying to find out. For example, we might try and find out this weird kind of, I don't even know how to describe that sort of shape. It's like that whole shape with this sort of piece cut away from it. And that idea of a piece being cut away from it is the concept that happens in this kind of topic. Now, there's two main ways that you could think about doing the integration with this one, right? And these two main ways, it's going to come down to what your personal preference is. And you will probably need to use both of these ways in your time of studying maths to try and find out what these areas are. So how could we try and find out this blue area that we've got here? Has anyone got any suggested ideas of what I can do to find that blue area? And you could all, there's nothing that I need to tell you here. You could actually just come up with this idea yourself. What do you think, Ishraq? Okay, so we're definitely going to need to find the solutions between the two lines as a starting point. That will tell me what?
That will tell you where they both meet, and then you can use that for limitation.
Good. That's going to tell me where they meet here, and it's also going to tell me where they meet here. So I'll tell you what, before we even go ahead and do the rest of it, why don't we actually start doing this question? Because Ishraq has very carefully said, we are going to need to find out where they cross, because then it's going to tell me what this value here is. And that sounds like it's probably going to be something that we need. So this brings us right back to what we did months ago now with me on simultaneous equations, right? So my two equations are y equals x, 4 minus x, and a very nice equation, y equals x. So to solve them simultaneously, we can just make them equal to each other. So x equals x, 4 minus x. So x equals 4x minus x squared. Rearrange this, I'll put it all on one side. We get x squared minus 3x equals 0. What's the best way of solving that? Pardon? Oh, come on. X and x minus 3. So x is 0 and x is 3. Now, we knew that x was 0 because if the diagram is going through the origin, it's going through the origin, right? You don't need to actually really work that one out. But we know that's going 0, 0. Now, if this x coordinate is 3, what would the y coordinate be? 3. Good, because the other line is y equals x. So if the x coordinate is 3, the y coordinate is 3. So this coordinate here is 3, 3. Now I can get rid of that question mark because I know what's there. So that was the starting point. Ishraq said to me, well, we're going to need to find out where they cross each other. We definitely need to find out where these curves cross each other. But that's not got me quite to the bit now of finding out the area of that blue shape that we've got there. Who thinks that maybe this time when we've been thinking about this, who thinks they've maybe come up with an idea of how we could find out what that area is?
Can you use that as a triangle?
Exactly. We can find out there's a triangle here, right? There is a triangle that we've got here. Now, when you integrate underneath this curve here, if I integrate it between 0 and 3, this is the area that it would find. Okay, so that yellow area, I'm just going to write out, the yellow area is the integral between 0 and 3 of x, 4 minus x dx. Exactly. If I take away from that the triangle, I will get the blue area. So just imagine if you take that triangle, I hate it when it does this, and you take away the area of the triangle, you clearly get left with just the blue bit that you've got there. But I don't like it when it stays like that. So if you take away the area of that yellow section, you get left with the blue section. And that's exactly how we're going to solve this question. We're going to find out this integral. We're going to find out the area of the triangle. And then that's going to give us our answer. And we've got enough information to find out the area of this blue triangle. So why don't I start off and say that bit, because that's going to be the easy bit. The area of the triangle is base times height divided by 2. Yeah, because the base of the triangle is 3. I like to add some of these things to the diagram if it helps. The height of the triangle is 3. So it's just 3 times 3 times a half, or 9 over 2, 4.5. But just generally, we do prefer to work in fractions when we're in A-level maths, okay? So all I need to do is work out between 0 and 3 the integral of x 4 minus x dx. So between 0 and 3, I obviously have to expand this bracket first. Yeah, it's just an alarm going off. Let's just get over it. So we get 4x minus x squared. And when I integrate this, Kausa, what does 4x integrate to? 2x squared. And what does x squared integrate to? Good. Good. And that's between 0 and 3. So when I put the 3 in, I get 2 times 3 squared minus a third times 3 cubed, all minus 0, because we know when you substitute 0 and you're just going to get nothing. So that's when we work that out on our calculator, because I'm feeling super lazy. Is it just 9? It's just 9, isn't it? So the area will be equal to the yellow area, which I should really, if I use my highlighter again, that's my yellow area. Take away the area of the triangle, which is 9 over 2. And when you do 9, take away 9 over 2, you just get 9 over 2. And it's, people are asking what are the units. We say it's units squared because it's area. Okay, you don't have to write the units, but you've got it as 9 over 2 units squared. Now there's another way you could think about this question, and this is it my preferred way? Maybe, I'm not sure. The other way that we could have thought about this is we could do the entire thing just using integration. How could I find the area of this triangle, but instead of doing it as the area of the triangle, how could I do it using integration?
Use the of the y equals x.
Yeah, instead of doing it as the area of a triangle, I could just say, well, you know what I want to do instead? For this particular, if I'm looking at this graph and this graph, if I want to find out the area of the triangle, isn't the area of the triangle just the area underneath the line y equals x? So I could just integrate the triangle, which is the line, the equation of the triangle is y equals x. I could just integrate x with respect to x between 0 and 3. Now, if you do that, you'll very quickly see it's going to be a half x squared between 0 and 3, and you get a half of 3 times 3, which is a half of 3 times 3. So it's the same thing. That's actually what the area of the triangle is going to be from, right? Now, one last thing that we could have done here, because I am integrating this between 0 and 3, and this between 0 and 3, this entire thing, and sorry for the way I'm writing this out, this entire thing that we've got inside, oh gosh, I'm making a mess of this bit, I could rewrite down here as between 0 and 3, x 4 minus x. I could combine these two things together, this thing and this thing, because I'm doing this area take away this area. It's the same as this minus this, all at once. It's the same thing. Because you know with integration, you don't have to, if I'm doing them with the same limits, I don't have to work out that one with those limits and then do that one with those limits. I could just do the whole thing. And this is the integral of the top curve minus the bottom curve dx. And I've just done that using kind of language. So it's the integral of the top curve, which was x, 4 minus x, and the bottom curve, which is y minus x. And you can do that all at once, and you just get your answer straight away of 9 over 2. So I like that method. The thing you have to be careful of is that both of them have to have the same limits. Okay, they both have to have the same limits. You can't put two integrals together if they've got different limits for each other. It just wouldn't make any sense. So I know I've made this board a little bit messy here, but the note that I've got about the bottom curve and the top curve is written on the last page of your notes. So you may like to kind of put a star that says, you know, look on the last page of the notes if you want to see this. So I've said the preferred method, well, if the top curve has equation y equals f of x, and the bottom curve is y of g of x, the area between them is f of x minus g of x, where a and b are the intersections. Just like we had here and here. Oh, not here and here, sorry. Here and here, our intersections of the two graphs were the A and B parts. So you were allowed to do this preferred method of just subtracting them. You do the top one, take away the bottom one. And that's literally saying it's the area under the top one, take away the area under the bottom one. But I'm now going to show you an example where that doesn't work, okay? Because of the setup of it, right? This is asking for a different area, right? If it was asking for this, if it was asking for this yellow area, this total yellow area that I've got here, then what I could do the same thing, right? And you can now see it's the area between them. You could integrate 2x minus x minus 3, and that should give you the area. But I'm not 100% convinced by this, even now, when I'm talking about it, because this bit of the area is going beneath the axis, and it's just starting to make me think maybe it's going to give a negative area. So we just have to be a little bit careful if anything is below the axis, okay? So I'm going to try and show you this in a slightly different way. Okay, the diagram shows a sketch of the curve with equation y equals x minus 3, and the line with equation y equals 2x. Find the area of the shaded region OAC. So this is a different kind of region that we've got here. We're going to start off exactly with where Ishraq said before. What did he say? Find the solutions, find the intersections, because it looks like this is going to be an important thing. So I've got x and x minus 3. I'm going to make it equal to 2x to find out where they meet. So that's x squared minus 3x equals 2x. X squared minus 5x equals 0. So you get x is 0 or x is 5. So that now tells me this is 0, 0. I'm going to write that on. Oh, it's the origin, it's obvious. This coordinate that we have down here is 5, but I kind of want to find out what this coordinate here is. How would I find out what the y coordinate is? Times it by 2, because it's just y equals 2x. So the y coordinate here would be 10. So I have 5, 10 is the coordinate of C. Now, probably I'm going to need to find out what the coordinate of A is, because it's on the diagram. Can anybody tell me what the coordinate of A is? 3. How do you see 3? It is 3, but where does the 3 come from, Arisa? Yeah, because this graph is x minus 3, so it crosses at 0, and it crosses at 3. We've now got enough information to try and think, okay, well, I can't do the top graph, take away the bottom graph, because that's not the thing it's asking for here. And there are a few different ways of thinking about this one. But has anyone got any suggestions about how they might do this? Yeah, red one. So you could work out the triangle. Yeah, we're definitely going to need the triangle OCB. We're going to need that later. Well, we might need it at the beginning. So we're going to need that whole triangle. The base of the triangle is, and the height of the triangle is 10. So the area is 5 times 10 times a half, which is 25. Okay. What else do we need? Nabil,
You could use the semicircle area.
the curvy area at the bottom. Yeah. Yeah, if I find out what this little bit here is, why would I want to find out what that bit there is, do you think?
Because if you were to do like the same method we did last time, you could subtract that area from the curved area, and then that would give you the triangle area.
But we already have got the triangle area.
Not that one, I'm talking about OAC.
But this is not, OAC is not a triangle, because this bit here is curvy. So this is not, this bit here is curvy, so ABC is not a triangle.
If you worked out the curve, it'd be minus that little bit that's ducking underneath the x-axis. So if you work out what's under the x-axis, you can add that on.
But why would you want to add on, why would you want to add this area
Because it'd be
on?
it'd be taken away from the curves area underneath the y equals 2x.
But no, because the curves area underneath y equals 2x, underneath y equals 2x, it never goes below the axis. It would, underneath y equals 2x would be this. It doesn't go beneath the axis. It always is the area between the curve and the axis. So I disagree with Nabil and Ariful to begin with. I don't actually, at first I was like, oh, maybe they're right. We don't want this area down here. It's not going to be helpful because it's not going to help me. I've got this triangle. How can I go from this triangle to this weird sort of curvy shape? What limits do you think we should use? Taylor? If I use 5 and 3, what will I then do with the 5 and what will I do with this area, which I'll do in a blue here? If I work out exactly. If I work out the area, that blue area, I can remove it from the triangle and it will leave me with that yellow area that you've got there. This is a horrible question. I looked at this. Shahan saw me when he was doing his work. I went and looked at the question, and you saw me looking at it for a while, and I was like, which way do we do this? Which way should we do it? So you've got to do that same thing. If your teacher is pausing to think how you do it, you definitely need to pause to think, how am I going to do this? You don't need this area down here. So we're going to do the triangle, and then we're going to take away the blue area. So I might as well do my blue area in a blue colour. We're going to integrate between 3 and 5. What am I going to be integrating? The 2x or the x minus 3? Yeah, because it's underneath that x minus 3, and there's the axis. So I have x minus 3 dx. So that is between 3 and 5, x squared minus 3x dx. X squared goes to? A third, x cubed, and this goes to? Minus 3 over 2x squared, and we're going to go between 3 and 5. So we've got a third times 5 cubed minus 3 over 2 times 5 squared minus a third times 3 cubed minus 3 over 2 times 3 squared. So the answer for our area, and this is how I would write it down, I would say equals area of, and you can just draw a triangle if you don't want to write the word triangle, area of triangle, take away the blue area, which is 26 over 3. So it's 25 minus 26 over 3, which is 49 over 3 units squared. It's hard, I think this is a very hard question because our instinct with maths is to go, let's just answer the question. It's integration. I know what you have to do. You just raise the power and divide by the power. But you have to stop and you have to say to yourself, how am I going to navigate this question? What are the things I'm going to try and do? Once you've decided what you're going to try and do, by all means, plow on and do your best to get it done to that kind of standard. If you're still writing it down, please don't listen because it's not going to make a difference. If the question was something that was like this, you could do, and it wanted this area, because it's absolutely the area between the two curves, you can do the top curve minus the bottom curve and integrate them between that limit and that limit. This one is different because it dips below the axis. I would be careful if it dipped below the axis and it was still like that, because I can't quite think out in my head right now. I think we might have some problems with negative areas because it's going beneath the axis. If it's above the axis and it's just the area between the two curves, by all means do our method of one of them subtract the other one. But I'm telling you now, it is not always that. I've deliberately told you that with this one that says a harder one. So we've only got 10 minutes left. So what I actually think would be a good idea for us to try and do is the last question that we've got here. This one you can see, it's the area between the top curve and the bottom curve that we've got here. So you don't need to do any triangles or trapeziums or anything like that. So we'll do that to finish off, and then I'll set you a few questions for homework, and on Tuesday's lesson, we'll do some exam questions because I really want to make sure that we get this. Because tell you what, we do this again in year 13, but the curves start becoming a little bit more crazy, okay? So I'll leave us with this one to have a think about here, and that will be us done for the rest of the lesson.